What was this theorem called? Look in your notebook. We wrote it down yesterday. Good. Chord product theorem. Chord product theorem. Okay, because the product, it's telling you to multiply, right? So, all right, let's set up our multiplication equation. So I know that 3 times 4 is going to be equal to x times 7 minus x. All right, so now what do I do? What do I do? Distribute. Good. We're going to quick distribute. I got 12 over here, and then here I got 7x minus what? Minus x squared. Good. Okay. Now I have this quadratic equation. Is there a way for the x squares to cancel out? Anyway? No. Right? So instead of having them cancel out, what I'm going to do is I'm going to get all of my terms over to the same side of the equation, make it equal to 0, and then we can factor. Now, Perla is saying to subtract 12. You want to be careful. You want to be careful because the place where they all go matters. So it's like, do we want to go to the right side or do we want to bring those over to the left side? And I want you to think about which side will make the x squared positive. Everyone saying to the left. And Tyrone, you're right. You're right. Let's check out why. Because if I move the 12, if I say, okay, minus 12, I would get 7x minus x squared minus 12. And when I rearrange it, this is going to be negative x squared plus 7x minus 12. And what we don't want this negative. We don't want it there, right? Because in order to factor, you have to have a positive value. So instead of moving everything to the right side, which seems easier at first, it's going to be better to go the opposite way because then the x is going to be positive. So I'm going to move both of these guys to the other side. And when I do that, I'm going to subtract 7x and I'm going to add x squared on both sides. So I'm going to end up with x squared minus 7x plus 12 equals 0. So we see why. Does anyone have any questions on why I would rather move it to the left side instead of moving everything to the right side? Okay, so you just want to make sure that the x squared, that in the very front, it's a positive 1. Once that happens, you can factor it without an issue. So let's go ahead and factor. What are going to be my 2 factors? Four and 3. Now, good. Is it going to be x plus 4 and x plus 3? Or is there minuses or pluses? What's going to be the signs?
I have a question.
Yes,
So
Daniel.
do we want to make the lines equal, or are we going to have like one line, one more than the other one?
Which lines? The chords in the circle?
Yes.
They're equal. Their products are equal. So look at my first equation that I
So if
set
their
up.
products are equal, then wouldn't x be 1?
Why?
Because 3 plus 4 is 7.
Products.
7 minus
products. What's product?
Oh yeah, product is multiplication.
Mm-hmm.
Okay, 3 times 4 is 12. So
think about it. Do it your way while we finish doing it our way. Okay, we factored.
X would have to be 3.
Okay, so we factored the equation. These are my two factors, and from here, how do I find the actual solutions?
FOIL.
Nope, that'll just bring us back to standard form.
Oh wait.
Anyone else can jump in here.
Dang it, I forgot what it's called.
There, Emily's got it. So we split it up, set each of these equal to 0, and then solve for x. So what do I get? On the left side, when I add 4 to both sides, I get x equals positive 4. And on the right side, when I add 3 to both sides, I get x equals positive 3. So there's two solutions, aren't there? There's two
Three
possibilities.
makes the most sense.
Are any of these negative?
No.
Nope. So what happens is there actually are two solutions. You can use both and it'll work out both times. And you can plug it in just to check.
Give you the same product?
Yeah. So let's plug it in and check. If it's 4,
Oh, that's true.
you get 4 over here,
No.
4 over here, right? So 4 times 3, we get 12. If it's 3 instead, it's still going to work. Because if I have a 3 over here and a 3 over there, it also works out.
Okay, I understand now.
So there are two solutions. Good. And yeah, Jalen, you had the right answers. You just had them negative. And that's something you can also remember is that you can't have a negative distance in the real world. So if one of those was negative, then it wouldn't make sense. But since both of those are positive, they both make sense and they both work. How do we feel? Any questions on this whole problem?
I'm good.
Okay, cool. Awesome. Okay, so today we're continuing with looking at circles that are where we have intersecting chords. But it's actually, the actual lesson today is pretty short. So if after we learn the new stuff, you guys are going to have a few practice problems that cover everything that we've already done. So everything from last week and then everything from yesterday. So it's a good kind of review day. All right, I have another link for you guys. Let's check this one out. Okay, here we go. It's going in the chat. Go ahead, click on the link. Same as always, take a few minutes to play around with it, move things around, and then see if you can answer the question below. The question is, what is the relationship between the interior angle and the two intercepted arcs? So take a little moment, take a few minutes, play around, and we'll come back in a moment. Okay, take about another minute or so. Keep playing around. If you notice anything interesting, you can send me your answer in the chat. All right, so start to come back over to the Zoom screen, and I'm going to share the same website.
I don't
Here we
know the
go.
relationship. Like at first, I thought that
You,
the moving that green thing on the left, I mean the right, affected the size of the angles. It seems like it's
mhm.
true, but I don't know what else.
Okay, so as you move things around,
Oh wait, that's what affects the
obviously,
arc,
you know,
but
yeah, as we move this around, it changes the value of this arc right here. And it also changes the value of that central angle because it's making it bigger, 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 and then smaller, 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 smaller. However, there's one relationship that remains constant. And I think Perla noticed it. I want to see if anyone else notices it. So I'm going to leave it right the way it is right now. Look at those three numbers that we have and see if you can figure out the relationship between the central angle and these two arcs. Take another 30 seconds using these numbers. See if you notice it. Well, I'm not changing anything. So I'm leaving it on the way it is right now. So nothing is changing. But when I leave it with these numbers on the screen, see if you can figure out the relationship between the central angle and the two arcs. Okay. Anyone notice? I have a 100, and then I have 120, and I have 80. What's the relationship between those three numbers? Perla, go ahead and say it in the chat, please. The measure of the angle, of the central angle, is half of the sum, the addition or the sum of the two arcs. So let's look at our arcs. 120 plus 80, what do I get?
2 million.
2 million. 180 plus 20, we get 200. And then 200 divided by 2 gives me 100. Do you see that? Okay, now let me move it around and let's see if that's still true. Okay, move that one, move that one. 46 plus 93, what do we get? What's 46 plus 93? Not 140. Wait, oh, I think it's a little bit off. Hold on. Yeah, it's 139, but I think it's just a little bit off because it's, there we go. Okay. 46 plus 90, 93 plus 47. There we go. That should work. There we go. Now we got 140. So 93 plus 47 is 140. And then 140 divided by 2 gives me my 70-degree angle. Right? So this relationship is true no matter where you go, no matter where. I can move this all the way around to any different location, and it's still going to work. And so that is called, we'll go back to my other screen. There we go. That is called intersecting chord angles theorem. So let me go ahead and write that down. Intersecting chord angles theorem. So what it's telling me is that the central angle is half the sum of the intersected arcs. Intersected arcs. Okay, the central angle is half the sum of the intersected arcs. So in my example over here, 110, the central angle, is equal to 1/2 times 140 plus 80. All right, does anyone have any questions on the intersecting chord angles theorem? Okay, is anybody still writing it?
No, 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 no.
No, we all good? We wrote it down? Okay, let's do a few examples then. Here's the actual theorem, but we already wrote it down, so we're not really going to copy it. Oh, I forgot. We're gonna do a proof. Let's figure out why. Oh, guys, this one's so easy. You only have to fill in like 3 blanks. Don't even give me the complaints. Let's
3 million?
Let's just see why the intersecting chord angles theorem works. Let's see why it works.
Man.
So, starting with, let's kind of follow along and just see what they did already, and then we'll go from there. So they're telling me that, okay, AD and BC intersect at point E. That's given. Then we're going to draw BD because you can. Because through any 2 points, there is exactly 1 line. So they drew that extra line, BD. Then it's saying that the measure of angle 1 is equal to EDB. Let me go highlight them. EDB plus EBD. EBD plus this one. So they're telling me that angle 1 equals angle B plus angle D. This is an old theorem. I think we learned this like in the first week, one of the first weeks of school. So I'll be pretty surprised if someone remembers this one. But I want to give you guys a chance. Does anyone remember what this theorem is called? For number 3, yeah. I'll give you a hint. Where on that triangle is angle 1 located? It's similar to the triangle sum theorem. So Tyrone's on the right track. It's similar. Okay, angle 1 is a vertical angle, but it's also, if you think about that triangle, that where B and D are located, that triangle, is angle 1 part of that triangle or no? No, right? But where is it located? in reference to that triangle. Kind of in between, kind of, it's not angle addition postulate. It does not start with a T, it starts with an E. Like I said, I would be pretty surprised if anyone knew this one because it goes way, way back. EX. Nope. Nope. This is like a game of hangman. EXT. No. Close. Emily's got it. Exterior angle theorem. It's a really old, like, I think we literally touched on it once and then never again. So like I said, I would be pretty surprised if you remembered it. But basically the exterior angle theorem just says that these two angles will be equal to the exterior angle. So if this is 1, this is 2, and this is 3, angle 1 plus angle 2 equals angle 3. Do you remember that? It's like really, it was a long time ago. It was a long time ago. But anyway, see, it came back. So sometimes these theorems, they even if we learned them like 50 years ago, they still come back. So that is my exterior angle theorem. Okay, then let's check it out. So any questions on the exterior angle theorem? It's not super important to have it memorized right now. It's just that it came back, even though we learned it a long time ago. So any quick questions on it? Don't stress about it. It is not on your test. It's okay if you don't remember it. We will review it when it's time. Okay. Then what happens? Okay. Then they tell us that EDB is half of arc AB. And EBD is half of arc CD. So here's arc AB, and here's arc CD. What's that? What is that all about? It does have a name. We've been working on it all along. Yeah, it's the inscribed angle theorem. That's literally it. Because here's one slice. Here's my inscribed angle and the intersected arc. And then here's my other inscribed angle and its intercepted arc. So that is just simply the inscribed angle theorem. Okay, and then they're saying, okay, angle 1 is equal to half of AB plus half of what? CD. Good. And then finally, we know that angle 1 is half of AB plus CD. Now, what did I do mathematically to go from step 5 to step 6? Think about mathematically what I just did. I'll zoom in a little bit too so you can see it. Look at step 5, look at step 6. What did I do? I simplified, but there's a more specific word for what I did. It's a property, kind of. No, it's not really substitute. Oh, Perla got it. Yeah, I didn't see factoring. Yeah, because what did I do? I had a 1/2 over here. I had a 1/2 over there. Whoop. I took that 1/2 out. Took it out. And now I have parentheses. So we factored. It's just factoring. It's just plain old algebra. So there we go. We did our proof. Take a look through it. See if there's any part of it that you have any questions on. Anything? Any questions? Any part of it that doesn't make sense? Why were proofs invented? So that we could think critically. Yes, we do need them because it's important to know why things happen. You can't just make things up. You got to have a reason. Okay. All right. So continuing on now, couple of problems to do together. So now that we have our theorem, we should be pretty capable of figuring these out. So first one, find the measure of MPK. MPK, so we're finding the measure of the central angle, MPK. What do I do? Perfect. It's 1/2 of 61 plus 111. 61 plus 111 gives me 172. And what's 172 divided by 2? 86 degrees. Simple. Not too bad, right? Now, if MPK is 86 degrees, what's this one over here on the other side? NPL. It's the same. What type of angles are they to each other? They are vertical angles. So whatever one of them equals, the other is going to be the same. And what would this equal? The blue, KPQ. Not the same. There we go, 94 degrees. How do we know that? Good. Altogether, the four of them have to make 360 degrees. And the ones that are next to each other have to add up to 180 because they are a linear pair. They're next to each other on a line, so they have to add up to 180. So you could have also done 180 minus 86, gives you 94. All right, try number 5 on your own. MPR, or just PR, is what we're finding. PR, this arc. All right, Perla says 34. Let's see if we agree or if we disagree. Rios agrees. All right, Tyrone agrees. Good. So we know that the central angle, so 58 degrees, is equal to 1/2 times 82 plus, we can call that x. If we don't know what it is, we can call it x. So we multiply 58 times 2. What's 58 times 2? We get 116. And then take away 82. 116 minus 82, we get 34. 34 degrees. How do we feel? Any questions so far? Cool. All right, let's do another. So now we're just going to do a few of these. There's really not that many practice problems. And then afterwards, I have a lot of practice problems like about everything else that we've been learning. So we'll do a few of those after this. So try this one on your own. Same thing, send your answer in the chat when you have it, and then we'll go through it together. What is the value of x? Independently. We'll go together afterwards. I'm going to wait till I see an answer from 6 out of 8 students. Right now I've got 2. Oh, there's only 7 students. Well, 6 out of 7 then. I have 3 answers in the chat so far. What do you think I'm drinking, Perla? It's always the same. It's tea. All right, I have an answer from Rios. I have an answer from Perla. I have an answer from Tyrone. I have an answer from Jalen. I'm still waiting to hear from Daniel, Samaj, and Emily. Send it in the chat, Daniel. Tyrone did. You chose what college I'm going to go to? That's not how you spell Harvard. If you ever want to go to Harvard, you better know how to spell Harvard. I did not get into Harvard, unfortunately. Well, I didn't apply there. So, Emily, Samaj, Daniel, I'm still waiting on replies, guys.
I'm trying to figure it out.
It's not hard. It is not hard. This is easy stuff. I just did how many problems? 1, 2, 3 problems. 4 problems. I did 4 problems about it already. If you don't know how to do it yet, that means you were not paying attention. Tyrone, what's my answer? 112 degrees. How did you get it? $112. Hold on, that's not what you wrote. You wrote 122. My bad. 22. Okay. Added 170 plus 74. Daniel, what's 170 plus 74?
244.
244. And then 244 divided by 2 gives me my answer, 122 degrees. You add up the outer arcs, divide it by 2. Is that hard?
No.
That's not hard. It's very, very easy. So if you didn't know how to do it correctly, that just tells me you were not paying attention to what a word that I said, which is a problem. Because I don't have to teach this twice. This is very, very simple. Pay attention the first time. Here's a poll. If you don't get 100%, if I don't see 100%, I'm going to give you guys an extra pop quiz at some point this week. I want to see 100% correct, and I want to see 100% of students voting. Everybody has to participate. Independently.
Dun-dun-dun-dun.
Okay, I have 3 students have put their answers in so far. Rios, put it in correctly, please. I have 4 answers in. I have 5 answers in. I'm missing 2 more. I'm missing 2 more. Let's go. Six answers in. If I don't get that last person, y'all are in for a treat later this week. Jalen, did you put it in? Okay. Who's missing? Rios, did you put it in? Okay. Emily, did you put it in? Yep. Okay. Daniel, you put it in. I know he did. Okay.
Yep.
All right. Okay, then I know who's missing. All right, here we go. Good. 100%. Easy, easy, easy. If this question comes up on a test, guys, and somebody gets it wrong, I'm going to be very upset. This one should not cause you any issues. Answer choice D. Any questions on this? Yeah, no, Rios played nice this time. Okay, last one, I think. No, we're doing 2 more. Same thing. This one's a little bit different, so be careful with it. But go ahead. All right. Stop bickering in the chat. Answer the question. Hold on, there's an issue with this one. Hold on. I think I know what happened. Let me see if I can figure out what happened here, guys. Hold on 1 second. I think that when they made this question, they labeled it incorrectly. Okay, so the answers in the chat aren't, or the answer choices are not correct. So send me your answers in the chat. What is the value of x? Oh, wait, hold on. Oh, never mind. The answers are right. I'm being silly. Hold on. Try again. Look carefully. Don't make the same mistake I did. I have one answer in the chat. I'm not going to say anything. Work it out.
This is just backwards.
Work it out. Yeah. Work it out. I promise you, it is one of those answers. Rios, no need to be snarky. We don't do snarkiness in this class. Two answers are in. Well, I don't like it, Rios. Whether you like it or not is not the point. The point is what I like, and I don't like it. So stop it. I have three answers in.
Wait a second, this is kind of confusing.
Okay, some of you guys are figuring it out. Good. I'll give you guys 30 more seconds. All right.
I got it wrong.
Let's see. Let's see. Everybody got their answers in? I'm missing one more person. If you don't have anything in, just guess. Take your best guess. Okay. So here were my answers. 4 of you got it right. 4 of you got it right. So the trick comes down to remembering, first of all, using your eyes, which I didn't do originally. I made the same exact mistake. If these are my arcs, I have 45 degrees. Hold up, it's not writing. I have my 45 degrees. Hello. doesn't want to write. What is going on? Okay, I don't know why it's not writing, but if this is one of them and it's on the other side, the angle that you get when you add them up and divide by 2 is the smaller of the central angles, not the bigger one, not 122.5, but the smaller one. So what is the value of that smaller angle? Right here, there we go. If the bigger is 122.5, how much is the smaller ones? The blue angles. Anyone? Those of you who got it right, this is the way to do it, so you should already know. What's the measure of those smaller angles? 57.5. Because together they have to add up to 360. So if that's 122.5, this is also 122.5. And then the other two are each 57.5. So now I have everything I need. Now I know that 1/2 of 45 plus x equals 57.5. And the only answer choice that works out is answer choice D. Because if you try to do it backwards, so now I have to multiply, 45 plus x, multiply times 2, what's 57.5 times 2? I got 115. Subtract 45 from both sides, I got 70. So 70 degrees. If you were trying to do it and you kept coming up with the answer 57.5, you should have realized that it's the other two angles that we're talking about. Any questions on this one? Those of you who got it, good job. If you got it, good job. But do I have any questions, especially if you didn't? How did I get 57.5? Who can tell me? How did I get 57.5? I know Perla got it. I know Rios had it. How did you guys get 57.5? So that's one way to do it, but there's a much faster way. Much, much, much faster way. You guys are doing twice the work. Yeah. All you have to do is subtract from 180, because these two angles are on the same line. Think of that. They're on the same line, so together they have to add up to 180. So 180 minus 122.5, I get 57.5. Just subtract from 180. There we go. Questions? All right. Last one of this topic. This one should be pretty easy now, actually. Should be pretty easy. Go ahead. And then we'll move on to some other types of problems. Rios, what's your question? Make sure it's relevant. I did tell you that earlier. You just didn't hear me. Or I don't know, you weren't paying attention. All right, I have 4 answers in, waiting on a couple more so that we can move on. Let's put them in. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. 5 out of 5 got it right. 2 out of 5, 2 out of 7 did not answer.
Hey,
Don't know
I
why.
think I answered. I'm
Okay.
pretty sure I answered.
Pretty sure or definitely sure?
Definitely sure.
Okay. It is answer choice C. 40 plus 92. 40 plus 92, I got 132. Divide that by 2, we get 66. Answer choice C. Questions on this one? All right. Now we're going to do a few review questions. So going back to stuff we've been learning in the past few weeks. So take a look, same idea. We're going to do some polls with all of these questions. So I want everyone to try it out on their own first, and then we'll review how to do each one. So start with the first one. I'm going to give everybody 2 minutes per question. Just 2 minutes, because I want to get through them quickly. All right, I have C 2 answers in so far, but there's only 10 seconds remaining, guys. So make your best guess if you got a guess. 5, 4, 3, 2, 1. Best guess, best guess. Here we go. Here's the results. A and B are pretty close tied. C and D, not so much. But again, we're looking for best guesses. So if they're talking about angle BAD, BAD is an acute angle. That's a acute angle. So answer choice D is a bad guess. That's not a good guess. So get in the habit, if you got to make a good guess, make it good. That's an acute angle. That's not going to be 110 degrees. It's going to be less than 90. So D was a bad guess, whoever chose that one. But let's look at the rest. Okay. ABC is 30. ABC, 30 degrees. CAD, 140.
B makes the most sense.
B might look like a tempting answer, but let's talk about it and see if it's actually true.
Okay.
All right, so there's a couple of different ways to do this. One way is to notice what types of triangles I have here. Did anyone realize what types of triangles are these? There's 2 triangles there. What kind of triangles are they? Good, Tyrone's got it. It's a right triangle. How do you know that this is that both of these are right triangles? How do we know that? Close. It's not a tangent. There it is. So let me kind of erase a couple things so to make it really clear. Because we know that this is 180. And if the arc is 180, the angle has to be half of that. Half of that is 90. So that's 90 degrees. And same thing with the other one. This whole arc is 180. So the angle has to be half of that. So both of these angles are 90 degrees. The other way to know that is because that happens anytime you have a triangle where the hypotenuse is the diameter. So let me highlight that. Here's the diameter. If the hypotenuse is the whole diameter, it goes all the way across, then it has to be a right triangle. So both of these are right triangles. Okay, then let me relabel the other angles. We know that this one is 140. And we know that this one is 30. So from there, there's a couple more things that we can do. Because remember what I said, I know that this whole thing is 180. I know that all of that is 180. I also know that all of this is 180, right? What else do I know about these arcs? Is there another arc that we can highlight? CB. CB is 120. How do you know that? Okay. If we don't know, that's not a good answer. If you don't know, if you can't explain it, then you gotta think a little deeply. You're on the right track though. Is there anything else I can piece together? Any arcs, any angles, anything that we can figure out? There's a few different ways to do this problem. But the fact that I have utter silence right now is a big issue because you guys aren't even trying. You're not even trying. Perla tried. Perla tried. I haven't seen anybody else give me even a guess or anything at all. There's, like I said, there's like probably about 4 different ways to do this problem. And it's a puzzle that we need to figure out. But I'm not going to give you the answer. I'm going to just wait and see who says something. Arc CD. Which one's arc CD? There's two possible CDs. Is it CAD or CBD? CBD. How much would be CBD? CAD is 60. You're close on that, Rios. You're really close. Arc CD is 120. Nope, it's not 120. The one I highlighted, Jalen? The small one. So CAD. I'm just trying to piece together what you guys are saying. So I have the minor arc and the major arc. There's one of those that I know the answer to. One of those I know how much it measures based on what I've learned in the last week. And I must say, I'm a little disappointed right now that you guys can't figure it out. Okay, all right. I guess I will just show you the answer since we can't come up with it on our own. I'll just have to show it to you. Rio says it's B. Let's find out if my pen ever decides to work, which it doesn't seem to want to work. Yeah, it's charged. I've been charging it this whole time. I don't know why. Sometimes when I take it off the charger, it just takes a moment to connect. So I'm just gonna wait for it. See if anyone can think of anything while I wait for my pen to do its job. Don't know why. There we go. All right. CBD, arc CBD is 280 degrees. Why? Because angle CAD is 1/2 of arc CBD. 140 is 1/2 of 280. 280 degrees. Arc AC, 60 degrees. Why? Because angle CBA is 1/2 of arc AC. 30 degrees, 1/2 of 60. The remaining portion. Take it away from 360. 360 minus 280 plus 60. 360 minus 280 plus 60. 340. 360 minus 340, 20. If that's 20 degrees, then this angle is 10 degrees. We're looking for angle BAD, however. If that's 90 and that's 10, angle BAD is going to be 180 minus 90 plus 10, 180 minus 100, 80. 80 degrees. Answer choice C. That was only one way to do it. There are a lot of other ways. For example, another way to do it would be, actually what I think would be an easier way. In this, the triangle that's on top has to add up to 180, so the missing angle over here, 90 plus 30, 90 plus 30 is 120, 180 minus 120. I got 60, yeah, 60 degrees. If that's 60 degrees, and the whole thing we were told is 140, then 140 minus 60, I got 80. Both ways I got 80. Probably this way was easier, but I wanted to make sure that we're understanding these things that, guys, like we've been doing this for like over a week now. And if you're still not seeing it, that is a problem. That means you got to go back and you got to practice, because I haven't been giving you homework because Khan Academy doesn't have it. Like I can't give you something on Khan Academy because they just don't have a good resource. So just because I'm not giving you homework doesn't mean you got a free week. Because this question is showing me that we're not in a good shape, right? If I was giving you the test tomorrow, we would not be doing well on it. So we have about a week to shape things up, because from now till then, this type of question should be pretty easy. I did not think this was going to be a challenging problem, but here we are. We spent like 15 minutes on it. Do I have any questions? All right, let's do another one. I don't know how much time we have. We have like 10 minutes, so I might as well just go through this together. Consider the circle with a radius of 12 inches and a central angle that subtends an arc of 110. That just means that the central angle goes out towards that arc. Select the proportion that can be used to find the length of the arc. So we're looking at proportions. We've done this, it was from last week. Pick the one that is going to give you the correct response. 2 minutes. One minute left. I have 2 responses so far. Thirty seconds. Oops, someone said they picked the wrong answer. Okay, I'll take that into my calculations. 10 seconds remaining. Three, two, one, time. Okay. So disregard the one who chose C. That person meant to choose B. So it should be 4 votes for B and 1 vote for A. So, and that is correct. It is answer choice. It is answer choice B. So not bad, not bad. Could be better. I only had 5 people answer out of 7, but that is good. Okay, so it is B. There was a small trick to this one. Wait, hold on. Let me check this again. Is it B? Now y'all are making me doubt myself. Y'all are making me doubt myself. I'm not sure that it's B. So let's talk about why. Let's work through it and then see what happens. So usually we would set up our situation. Remember that you always want to do part over whole equals part over whole. You want to keep it consistent. You want to keep it consistent. So part over whole, well, that's going to be, for the angle measurement, that's going to be 110 over 360. So that's good. But what's the part? On the right side. What would be the part? Yeah, the length of AB is the part. What would be the whole? Circumference. Now the reason I just realized this is because I was looking and I realized that B and C, what's going on between B and C? They're flipped, and when you flip it, it's the same thing, right? Just flipped. So that should kind of tick you off that there's something going on, because if that was the correct answer, that would mean that B and C are both correct, which can't happen because this is a multiple choice problem. So if you ever notice that 2 answer choices are actually the same answer choice, just written in a different way, that should tell you that it's not going to be that answer because they're equal to each other. Those are both would be correct. If that was the correct answer, B and C would both be correct. So that's what I noticed first. But let's see if maybe there is a possibility here, because I don't know. They might just be flipping things around like crazy. I'm just gonna highlight things in different colors just so we can keep track of everything. Okay. I'm gonna cross multiply really quickly. I'm gonna cross multiply and then do something else. I'll write circumference as 2 times 12 pi, like they did. I'm going to keep everything the same color. Okay. What I can do here, I cross multiplied, but now I can divide. I can divide on both sides by, let's do this. So first I'm going to divide on both sides by, let me pick one. I'm just trying to see which one it's going to end up being. Okay, I'm going to divide on both sides by 2 times 12 pi. And you'll see why in just a moment. Okay, so this crosses out. I'm left with 110 equals 360 times the length over 2 times 12 pi. Now let me highlight everything again so we can keep track of it all. Okay, now I'm going to divide both sides by the length. I'm dividing on both sides by the length. On the right side, it cancels out. And so what am I left with? I'm left with 110 over the length equals 360 over 2 times 12 pi. Which answer choice does that match with? Answer choice A. So take a look at the original way that I wrote it and take a look at where we ended up. I'm going to put it up here, or I'll put it over there. No, where can it make more sense? I don't know. I'll just leave it where it was. So it was A, but why is it A? Look at the original one. Look at our final answer. What did they do? What did they switch around? Okay. The bell's about to ring, so what did they switch? Look quickly at the original and the final answer. Yeah, the length and the 360, they just switched their positions. So they brought the 360 up to here and the length down to here. And they kind of flipped where it was. And we did that a really long way, but we came up with the same answer. So this one was a very trick question. I didn't like this one, but does anyone have any questions on how I got to that final answer? Okay. All right, we're gonna tomorrow move on to a brand new topic. Guys, circles, you're gonna hate them by the end of this week. So just be keeping that in mind. Tomorrow's gonna be a kind of a tough one, all right? But I'll see you then. Have a good afternoon. Bye, everyone.
Bye, Miss.
Bye.